We see the sun rise in the east and set in the west every day. We live on Earth since when we were born, and we see many stars twinkle in the dark sky at night time. Where are they from? How were they formed? Those questions have puzzled humans for thousands of years. In this video, I'm going to explain how the sun formed, the formation of the solar system, and how all the observations support the Nebula theory mode of solar system formation. First, according to the evidence as we understand it today, the universe was born in the Big Bang. Hydrogen and helium were the only chemical elements present when the universe was young. All the heavier elements had been produced since the times by stars, though through nuclear fusion in their cores, or the explosions that accompany their deaths. When stars die, they release much of their content back into space, including newly produced heavy elements. This material can be recycled into new generation of stars. Like our sun actually is the third generation of stars. But how did our sun form from this solar nebula? The solar nebula probably began as a very large, roughly spherical cloud with very cold and very low density gas. This cloud collapse may have been triggered by a nearby star supernova. Once it started to collapse, gravity made it continue to shrink. As the solar nebula shrank in size, the temperature of the solar nebula increased as it collapsed because the cloud lost its potential gravity energy and was converted into the kinetic energy of individual gas particles falling inward. The sun was formed in the center of the solar nebula where the temperature and the density was highest. That's why our sun is the biggest object in the solar nebula, solar systems. Along with the temperature increase, the solar nebula rotated faster and faster as it shrank in radius by the angular momentum conservation law. The spanning of the solar nebula ensured that not all the material in the solar nebula collapsed into the center. Instead, the solar nebula flattened into a disk. In the center of this disk is the protostar, like the picture shows. The evidence that our ideas about the formation of flattened disks are correct comes from many other structures that we already observed in the universe. As the protostar gained more and more gas from the surrounding nebula, the temperature of the protostar was getting hotter and hotter. The protostar continued to shrink by gravity until nuclear fusion started and generated enough energy against the gravity. The core temperature and the rate of fusion therefore increased gradually for a few tens of millions of years. At the same time, the protostar surface temperature began to rise when the primary energy transports from the core and converts into radiation. At this point, the protostar is main sequence phase, which means our sun was born. In the surrounding disk, different materials condense at different temperatures. Close to the protostar, the temperature was too hot for any material to condense. Near what is now Mercury's orbit, The temperature was low enough for mantles and some kind of rock to condense into solid particles. Those tiny solid particles were able to stick together by electrostatic forces. Therefore, the small particles began to grow into bigger ones by absorbing more materials around it. As the particles grew in mass, gravity started to aid the process of their sticking together, accelerating their growth into planetesimals, which means piece of plant, as the following picture shows. That's how the Mercury, Venus, Earth, and Mars formed. Beyond the forest line, where it was cold enough for hydrogen compound to condense into ices, the solid ices of plants were built of ice along with some mantle and rock. When the ice grew big enough, their gravity could capture and hold some of the hydrogen and the helium by surrounding them. As the growing plants accumulate gas, their gravity grows stronger and that allows them to capture even more gas. That's left over in our solar nebula. Ultimately, the Jovian plants grew much bigger than those terrestrial plants. According to the nebula theory, we can understand how our solar system was formed. We already knew that our solar system was formed the galactic recycling. Eventually, our sun will burn out its hydrogen and die. Based on all the observations and researches, our sun will become a supergiant red star, eject its outer layer into space. And in the center of the sun will become an Earth-sized white dwarf, and will be colder and colder, darker and darker, and gradually will fade out. That's our destination. Thanks for watching my video.